In this problem, we want to find the critical numbers and open intervals which function is increasing and decreasing. So we've got f of x is equal to 5x minus 3, x squared plus 3, and this is when x is less than or equal to 2. Well, little tablet isn't doing it. It's got little places where I can't write. Okay. Suppose it's time to get another one. Okay, step 1. We want to find our derivative. Now, taking the derivative, we take the derivative of everything where it's sitting. So derivative of 5x minus 3 is 5. Derivative of x squared plus 3 is 2x. Now, step 2, find our critical numbers. We're going to set each one of these equal to 0. So I'll set 5 equal to 0, and I'll set 2x is equal to 0. Now, 5 equals 0, we just drop that because there's no x to solve for. But this one, we divide both sides by 2, and we come up with x equals 0. And that's one of our critical numbers. Now, by default, the number on your condition, when I say the number on the condition, I'm talking about this right here, that number is by default a critical number. You always want to check it. So we're going to put x equals 2 down here also. Okay, so build our table of intervals. We got x equals 0, and x is equal to 2. And clear over here is negative infinity, clear over here is positive infinity. We want to choose test cases. We want to choose some value between negative infinity and 0, like negative 1. We want to choose something between 0 and 2, like positive 1. And we want to choose something greater than 2, like 3. Now, we want to plug this into our derivative, and this is kind of the tricky part. Notice our condition is 2, so the 2 is where it switches. So this is where it switches. So for this test case and this test case, we're going to plug it in to this first piece, because that's where x is less than or equal to 2. Less than or equal to 2 is to the left of this value. Now when we plug it into this, we get 5. Well, there's no x to plug it into, and 5 is by default positive, so this is increasing and this is increasing. Okay, now over here at x is greater than 2. X is greater than 2 is to the right of this, and we're going to plug it into this second piece, the 2x. So we got 2 times 3, which is 6, which is positive, so it's increasing. So our answer, it's increasing from negative infinity to 0. It's increasing from 0 to 2. And then it's increasing from 2 to positive infinity. Now specifically, when we found these critical values, this x is equal to 0, and here we got x is equal to 2. For this first piece, even though we came up with this critical value from the derivative, for this first piece it's just a line anyway. And a line actually is increasing from negative infinity to 2. So you could set it up that way. It's obvious that this is increasing because my slope is positive. And x squared, when you got a positive number in front of your x squared, it opens up, so I know it's increasing at certain places. And actually, x is greater than 2, if I were to graph it, it makes sense that I get increasing everywhere. But there's nothing wrong with leaving it separate like this. I'm happy with that for the homework. So that's our answer.